red LEDs are on, and the intensity changes as I move across the screen. Okay, I'm going to show you how to build the robot control using simple parts. And before we build, I would recommend put on rubber gloves, because those electronic pieces may have lead in it. So I don't want to touch those and then put in my mouth, and especially kids, I don't want to get lead into my mouth. So rubber gloves, although it's optional, it's recommended. So I have several pieces in here: the breadboard, the microcontroller, ATmega 328P, the Bluetooth module, and a voltage regulator. The Radio Shack part is pretty good, and so I only need a small one, and this one works well. So the microcontroller, this one is ATmega 328P, and it's pre-programmed, and so it has the robot control firmware on it, and you can get it from eBay. So the first thing I do is to put the microcontroller on the breadboard. Okay, I leave one space here for the LED and resistor later. So that's the first piece. And then we have the voltage regulator, and in my case, because I'm going to use the Bluetooth module, and this requires a 3.3 voltage power supply. So because of that, to simplify things, I will also power the microcontroller using the 3.3 volt power supply. So let's put the voltage regulator, and this one is a 78L33, and it provides 3.3 volts. The input can be anywhere from 5 to 20 volts. Okay, let's put it right here. Okay, the next thing is to put Bluetooth module on the breadboard. So the Bluetooth module is very small. There are many pins, and the spaces are really small, but we only need 4 connectors, and there is 2 here. There is the TX, RX for transmitting and receiving, and we have the power positive and the negative, and there are many other pieces, but essentially we need these 4 connectors. So we have 4 wires here. So in fact, in order to receive signal and then send to the microcontroller, I only need the TX wire. So the RX wire is just going the other way, going backwards. So that will be needed later, but for now I just need the TX wire. So the TX is connected to the TX on the Bluetooth is connected to the RX on the microcontroller. So this is sending and this is microcontroller is receiving. So I usually use a tweezer to push it in. So the power connect to the power supply, the positive, which is in orange, I put in the positive for the power supply, and the negative goes to the one in the middle. Okay, so we have 3 pieces put on the breadboard. So the idea is your cell phone, the Android phone, sends a signal to the Bluetooth module, and the Bluetooth module will send the signal to the microcontroller, and then the microcontroller, which is a small computer, and will take the instructions and turn on and off the motors. We'll connect the power to the microcontroller, and the positive from here, from the voltage regulator to pin number 7. 1, 2, 3, 4, 5, 6, 7. Okay, and then the negative ground goes to pin number 8. So now my microcontroller has power. I also need to put in the power for the voltage regulator, so which is the battery, and I will need to connect to the ground, which is the common in the middle, and to the battery. So this goes to the battery, so it powers the it sends the powers up the voltage regulator, and then the rest of it is receiving 3.3 volts. It powers up the Bluetooth module and the microcontroller. So in addition, the microcontroller has an indicator light LED. So when it's power on, it will light up, and when it's connected to the Android phone, it starts flashing. So I connect that, and then I need a resistor to connect to the LED and the ground. Okay, so that's all we need, and that's pretty simple. So now we can power up and then send the signal to the Bluetooth, and then the signal goes to the microcontroller, and the LED will start flashing, and then as I send the signal control the motors, there are 4 pins PWM outputs from the microcontroller. That's the OC1A, OC1B, OC2A, and OC2B. So those 4 PWM channels control the direction and the speed. So when it's connected, you can see the red light is flashing. So that means it's getting signals from the app. So now let's move this around and see what happens. So move up, and you can see the two red LEDs are on, and the intensity changes as I move across the screen, and that can move the motor forward. So one on the left motor and the right motor, and also you can move to one side or the other, so it will control the intensity of the light, and it in turn controls the speed of the two motors. So that will change that will let the robot make a turn. So if I move down, the green lights will turn on. So again, the intensity depends on the location on the screen, and controls the backward movement of the robot. There are two additional pieces we will need to put in. That's the capacitors. The capacitors are basically act as noise filters, because the motor generates a lot of noise. So we put two capacitors between the positive and the negative pin of the power goes into the microcontroller, so to stabilize the power supply. And we put another capacitor, and this one has 10 microfarad, and so these two will pretty much filter out the noise from the motor. So next I will show you how to connect the robot control to the H-bridge. Using the H-bridge here is a simple H-bridge chip L293D. That's all for now. Thank you for watching. See you next time.